chemistry and you are watching Chem Science.
In our earlier video of mass spectrometry, we had studied that how mass spectrum and mass spectrometry is used to analyze or deduce an organic compound, how mass spectroscope works, and we can also analyze the organic compounds along with the isotopes with some examples of the organic compounds. In this video, we will study what is M and M+1 peak in mass spectrum, how to deduce the number of carbon atoms present in an organic compound with the help of it, with some examples. Let's understand that with the help of an example, and here I have taken the same example which we had studied in our earlier video of butane. Now this is the mass spectrum of simple straight chain butane, and we had also seen that the main peak at 58 mass to the charge ratio is due to the main molecular ion of C4H10+. So this is the main peak. Now we had also seen that along with the main peak we may get a very small tiny peak. Now these are the peak of M+1. So here is also M+1 peak. So the main peak is called an M peak, that is mass due to some fragment of the molecular ion, and the small peak besides it with +1 mass, that is M+1 peak. Here also we can see there is a small tiny peak of M+1 peak. Now this is because of the presence of one of the carbon as carbon 13 mass. Now this carbon 13 will obviously increase the mass of that fragment or molecular ion with +1. That is the reason that the butane ion have a mass of 58, but if one of the carbon present is C13 in place of C12, then we may get a small peak at 59 mass to the charge ratio. Here also it's same. Here we are getting another peak at the mass to the charge ratio 44. Now this is, as we have seen, it's due to the presence of one of the carbon as C13. So if there is C4H10 butane ion, then there might be C3H10 where this C3 may be 12 carbon, and there is one more carbon atom with the mass of C13, and that is how and peak at 59 is produced. Now same applies here at 43. The main peak of 43 is due to the C3H7 ion, but then M+1 peak may be due to C2H7 and one of the carbon as C13 mass. So the other two carbon had a mass of C12. So this is how an M+1 peak is produced along with the main peak of M. Now we had also studied the mass spectrum of 2-hexanon earlier. 2-hexanon is CH3CO C4H9. In this mass spectrum we had also studied that how different peaks at different mass to the charge ratio are produced. Now in this mass spectrum also we can see that there are tiny peaks besides the main peak, which are again M+1 peak. Now how are these M and M+1 peak are used to analyze an organic compound? Let's understand that. Now we can use the presence of M and M+1 peak to find out the number of carbon atom present in an organic compound. So here is a formula which denotes that N is the number of carbon atoms present in an organic compound. Now how can we find out that? Here is a formula to find out the number of carbon atoms. Now this is 100 upon 1.1 into the abundance of M+1 peak upon the abundance of M plus peak, that is the main molecular ion peak. Now abundance is important, and why 100 upon 1.1? Because the mass ratio of C13, that is the abundance of C13 mass carbon atom is just 1.1% in overall carbon atoms present. So that is the reason that we have taken 100 upon 1.1 into the abundance of M+1 ion peak upon the abundance of M ion peak. So this formula is used to find out the number of carbon atoms present in an organic compound, conditional that we should know the abundance ratio of M and M+1 ion peaks. So here is an example to understand that. Example says a hydrocarbon has a molecular ion peak at a mass to the charge ratio of 84 and its relative abundance is 62%. The M+1 peak ion has a relative abundance of 4.1%. How many carbon atoms are present in the hydrocarbon? Now here is the information given about the abundance of M+1 peak and M peak, and this information we can use to find out the number of carbon atoms present in an organic compound. So simple substitution is needed. N is equal to 100 upon 1.1 into abundance of M+1 peak. The abundance of M+1 peak is 4.1 divided by the abundance of M peak, which is 62%. So here if we calculate this, we will get a number of 6. That shows that our hydrocarbon contains 6 carbon atoms. So 6 carbon atoms are present in this hydrocarbon. Now this formula is as simple as that, and such questions are generally asked with the other questions of NMR or mass spectroscopy to analyze, or IR spectroscopy to deduce an information about an organic compound. So simple formula substitution will give you a idea of M and M+1 peak and the number of carbon atoms present in an organic compound.